Hello, this is Ben Welsh. You are back at First Python Notebook, and I am broadcasting live from Manhattan, USA. And we're ready for our next chapter, which is how that we use the indexing tool we learned in the last piece to filter our data set. So one of the most common, kind of questions that we might have when we're interviewing any data set relates to looking at individual subsets of the data. How many accidents happened this year? How many accidents happened last year? How many accidents happened in New York? How many accidents happened in California, right? And so there's ways in which you can easily formulate sort of questions you might ask the data based on based on subsets of what's inside of it, right? And the way that this is managed when you translate your question into computer programming is with the filter. Anyone who in this class who's learned the SQL language for working with databases, which is how I started my career as a data journalist, will realize that this is done using the where query, where you ask the system, hey, could you return for me a subset of records from inside your database where a certain condition is true, right? Where the LA Times make and model column equals Robinson R44 would be an example of asking the database to give you all of the records, right? Or all of the Robinson R44 fatal accidents as a subset. And those types of operations are managed in pandas using a similar syntax to the filtering technique that got us our column back, right? So the question that I want to ask to help illustrate this point and make this real is one related to the state column we saw in our data set. So even though I live in New York, I was born and raised in the state of Iowa in middle America, home to about 3 million people. And it is always on my mind anytime I look at a national data set. So even though it's not maybe the most serious question for this story, the question I'm going to ask it is, how many accidents, fatal accidents, happened in the state of Iowa, and when were they? And since we have the state column here in the database, that's something that will be no trouble at all if we figure out how to translate that question into computer code. And so I'm going to do it for the state of Iowa, but I urge everyone else here in the class to substitute in a different state, maybe the one where you live or the one that you're interested in. There are 50 of them. I'm sure you can come up with one. And so to do this, we're going to go down to the bottom of our notebook and we're going to make a new variable and we're going to do underscore my state. And you're going to do equal and then quotes. And then inside this variable, you're going to put the name of your state, right? Now, if we look at the head, the little peek at our database, we see that that column contains the 2-digit postal codes of each state. And as a loyal Iowan, I, of course, know that Iowa's 2-digit postal code is IA. So I'm going to save into that variable IA. You could substitute in here whatever state you like. I used to live in California. That's CA. I now live in New York, which is New York. I once lived in Missouri, which is MO. Feel free to put in whatever one you're interested in. And then, of course, you have to run the cell with the play button. Now, the logic of what we want to do is we basically want to ask the computer and pandas to return all the records where the state column of the data frame is equal to this variable. Now, before we learned how to access the LA Times make and model column using the indexing method. We're going to do the same thing here as we start out trying to filter by state. So in the same way that we did the flat bracket for that other column, we can do the name of our data frame, index with the flat bracket, quote, state. And if you run that, it will print out very simply a list of the postal code for each record in the database. That's start, right? So this is the column that we want to operate on. But now, to execute a filter, we need to create what computer programmers call an expression, which is basically a math formula that's going to return the answer yes or no, or in the language of computers, true or false, or maybe, as you've heard before, 1 or 0. Is this a record that I want to keep as the result of my filter, or is this a record that I want to discard as the result of our filter, right? And coming up with these little true or false tests, yes or no questions that you can ask a data column can then later be used to then filter the data set to only those where the answer is yes. And so in our case, the test that we want to set up as we convert our question into code is, does the state column entry for that row equal the my state variable, in my case, Iowa? And the way that you do a true false test like that in Python is you do two equal signs in a row. Anytime you do two equal signs, the computer is going to ask itself, is the thing on the left equal to the thing on the right, yes or no? And the result will be either a true or false, a one or a zero that the computer can then interpret. The reason that the expressions require two equal signs and not one is, remember, one equal sign has a different task. It's being used as our assignment operator to save things into variables. And so if you did one equal sign, the computer would think you're trying to save this variable into this column. And like we did before, it would change every single record to be IA, which we don't want, right? And so just to distinguish between cases where you're asking if something is equal from cases where you're assigning something, Python has decided to have two equal signs. And it's a very subtle but important difference in how Python works. It's mirrored in many other programming languages as well. And so if I put this little expression together, which is my kind of input, the test that I want to run, and then the thing I want to test it against, and I hit play, it then returns the result as a new series that's being computed and generated on the fly. And we can see that because none of the states in the little peaked sample were IA, in every single case, it's returning false. But theoretically, if there are any Iowa accidents within these 160 some rows, right, a few of them are going to return true. And those are the ones that I want Python to keep, pandas to keep, and to show me at the end. And so we're only halfway to where we want to be. We've set up the test, but we now need to use it to execute the filter against the data frame. So the way that we do that is we pass this in as the index to our data frame. So remember, we learned we could take our accidents list data frame and we could do the flat brackets to begin an indexing arrangement, right? That's why we pulled out that series earlier. But there's a lot of other things you can do with the index. You can pass into it a true false test, and then it will then execute a filter. So if I do the name of my data frame, I set up the index, and I then paste in that true false test, that expression, it's going to execute the filter when I run it. And we see right there, only 3 records are returned, right? And we can see that they're from 2006, 2013, 2006. And yes, they did occur in the state of Iowa. This one actually happened in my father's hometown of Walford, Iowa. This one in Clear Lake, Iowa, and this one in Macedonia. And we can see that 1 out of 3 was a Robinson R-44 helicopter. And so this basic arrangement of taking a data frame and setting up an index, and then you, the user, crafting a test that you're going to put inside of there, right, to return the result, is how you do filters. Okay? And now if I was to go back up and change it from IA to another state I lived in, Missouri, MO, and I simply hit play again, we would see that it now returns 4 records instead. And those 4 records are all in the state of Missouri, right? And so because the code stayed exactly the same, right, but the content of the variable changed, the result of the formula or the result of the function changed as well, right? And these operations don't only have to use my state, or I don't only have to use my state, and they don't only have to use a double equal sign. It's also possible when your columns are integers, like the year column or the total fatalities column, for you to use other comparisons like greater than or less than or greater than or equal to. right? So for instance, if I wanted to ask how many fatalities, how many fatal accidents had more than one fatality, it could be as simple as putting that column into the filter, changing the comparison to an equal, and then putting in the number 1. And so now we're going to ask the data set to return only those records where the total fatalities were greater than 1. We run that, and we see the list has gone up to 89 rows. And so we see 89 records with multiple fatalities. And if I scroll over, we can see in that column 2, 3, 2, 2. And so that while these findings we have here were not ultimately relevant to the story that we were published, you see how learning these fundamentals of how to put together a filter operator is a really powerful way to ask and answer questions of any data set. That's all for this chapter. We'll be back in the next one to learn an even more powerful tool, which is how we group data on common values, say on a particular column, and then begin to aggregate and add up the result of what's inside those groups.